The Monty Hall problem is a probability puzzle based on a game show called Let's Make a Deal. In the game, the show host, Mr. Monty Hall, presents the contestant with 3 doors. Behind one of the doors is a car, and behind the other 2 are goats. The contestant picks a door, and then the host opens one of the other 2 doors to reveal a goat. The contestant is then given the option to switch to the other unopened door. Should the contestant switch doors or stick with their original choice? The answer is that the contestant should always switch doors to maximize their chances of winning the car. But why is this the case? In this video, we will explore the Monty Hall problem and explain why switching doors is the best strategy. Let's say the contestant picks door number 1, and then Monty opens door number 2 to reveal a goat. This leaves door number 3 unopened. Now the contestant has some new information that they didn't have before. The car is either behind door number 1 or number 3. Before Monty opened the door, the probability of the car being behind door number 1 was 1/3 because there are 3 doors and 1 car. Since total probability must sum to 1, the probability of the car being behind other 2 doors combined must be 2/3. But now that Monty has revealed a goat behind door number 2, the probability of the car being behind door number 3 alone would be 2/3 because probability of the car being behind door number 2 is 0 now, as we know there is a goat behind it. This is twice the probability of the car being behind door number 1. Therefore, the contestant should always switch doors to maximize their chances of winning the car. Let's prove this decision is indeed correct by using the Bayes Theorem. Recall that the formula for Bayes Theorem is defined as follows. If you don't know what Bayes Theorem is, check out our previous videos from the playlist. We have covered it in detail there. In our case, B would be the event of Monty revealing a goat, and then A would be the event of the car being behind the other 2 doors. Since contestant has picked door number 1 and Monty has opened door number 2, we are interested in the probability of the car being behind door number 3 versus door number 1 given this new information. We know that the prior probability of the car behind door 1 and door 3 is 1/3. If the car is behind door number 1, Monty can pick either door number 2 or 3 to reveal a goat. This means the probability of D2 given D1 is 1/2 because he has only 2 choices to reveal a goat. However, if the car is behind door number 3, Monty has no choice but to open door number 2. This means the probability of D2 given D3 is 1 because Monty has no choice but to open door number 2. P of D2 can be calculated using the law of total probability as follows. We discussed the law of total probability in our previous videos as well. Please check them out if you are not familiar with it. After plugging the values in Bayes' equation and solving them, we find that the probability of the car being behind door number 3 is 2/3, and the probability of the car being behind door number 1 is 1/3. This confirms that the contestant should switch doors to maximize their chances of winning the car. I hope you enjoyed this video and found it helpful. If you did, please give it a like and subscribe to our channel for more videos like this. In the next video, we will start with a new topic called the random variables. Stay tuned for that, and thanks for watching.